Hi, welcome to another session in our course. Today we are going to be looking at list in Python. List is one of the common data structure in Python that as a Python programmer you are going to be using almost every time. And list is so dynamic that it is one of the very important data structures in Python. So what are lists? So lists are ordered collection of items that can be of different data types. So list is that type of data structure that can contain all sorts of data types. They are mutable, that is, we can change their content. So if we have a list and we want to change one of the member of that list, we can comfortably change it to any value that we want. Lists are created using square brackets. So when we want to create a list, we use a squared bracket. However, we can also use a list function to create a list. Let's get at it. Assuming I want to create my list, so it's my list, so I just put it inside this uh, square bracket. So I can say one, that is the first member, two is the second member, and then three is the third member. So if I call it back my list, so you can see now that we have our list. Now let me check the type. So you can see that the type of this particular data structure is a list. If you want to create a list again, like I said, you can use the list function. So assuming we have a, let's say we have a tuple. So if you check A, you can see that A is not a list. So let's look at the type of A. The type of A is a tuple. So if I use a list function, let's say tuple list, or let's say A list. So you can see now that this has become a list. So let's check its type. So now it's a list. So when we want to create a list in Python, these are the two basic ways. It's either we put our elements inside a square bracket, or we use a list function to create the list. Good. Now there is what we call an empty list. An empty list is when we put two square brackets but there is no element in it. So we call it an empty list. A good example is this. So let's call this our empty list. There is nothing in this list. We don't put any member or any element inside it. So let me call it back again. You can see that this is an empty list. We usually use empty list when we want to probably extract information from a particular settings, and we want to keep them in a new place. We can make empty list such a new place. For example, look at this code here. This code here is to extract all the integers which are divisible by 88 between 0 and 1000. And when we extract it, we want to extract it into a new place, and that new place is a new list. And that place, we make it an empty list, so that everything in that new list is going to be what whatsoever we have been able to extract in this particular code. So let me run the code, and then let me call my even number now. You can see now that from 0 to between 0 and 1000, we have been able to extract all the numbers that are divisible by 88. Good. The next thing is that lists can contain heterogeneous data type. Like I said before, lists can contain so many data types, and they can contain different data types. If you look at heterogeneous list here, we have 29, which is an integer. We have apple, which is a string. We have true, which is a boolean. We have 30.0, which is a float. And then we have this here, the whole of this is a tuple. All of these are put together inside one list. So let me call that list again. So now we have our heterogeneous list. So that is one of the very importance of a list. It can contain heterogeneous data type. Good. Now, lists are ordered such that if you have a list and we add another element to that list, the new element will be added to the new list based on the order in which it was added. For example, let's look at this again. We have a new list. We call it ordered list, which is 1, 2, 4, and green. Then we want to create another list which will combine our heterogeneous list. This is our heterogeneous list and the ordered list. So you can see that here now our ordered list comes first. Because our ordered list comes first, its member is going to be the first component of the new list, and the heterogeneous list that comes after is going to be the next list. So the members of the heterogeneous list are going to be the next members of this new list. So let's see. Now you can see that this is ordered list. This is 1, 2, 4, and green. Here we have 1, 2, 4, and then we have green. Now, heterogeneous list start from 29, isn't it? So, and you can see 29 to here. So, if I change it again, so let's make heterogeneous list the first and ordered list the second. And let us see what our ordered list has become. Okay, sorry, it's combined list. So now you can see that now the members of heterogeneous list has become the first members of this particular list, and the members of the ordered list are now the latest member of the particular list. So that is why lists are ordered. So if you are looking for that data structure that will contain your data and we put them in a list that in an order that you want to determine or define by yourself, then list is your guide. Let's look at the in and not in operators in list. If you remember, we spoke about membership operators, and we spoke about in and not in operators. So this is the areas where we will start seeing the importance of the operators that we discussed in the previous session. Now let's look at this. Before we go, let me show us combined list again so that we can. So we want to ask, is Apple inside combined list? So if I write this Apple in combined list, it's going to give us true, because truly we have Apple in combined list. Then we have that. So if I say coconut in combined list, false, because there is no coconut in combined list. So if I come here and say apple not in combined list, we have apple in combined list. So if we say apple not in combined list, what do we have? We are going to get a false, because that is not true. So we can get this. And the importance of this is that if you have a list that contain members in millions, then and you want to be sure whether a particular element is in that list or not, you don't need to be looking through the whole elements in the list. No, just use this method and believe me, you are going to see whether that particular element is in that list or it does not belong to that list. But be careful, because like I said when we were doing data type, for example, this is apple. If I put a space here, so this space is a string. So if I say this now, that is this in combined list, is going to say false. Why? Because this space this apple with a space is different from apple without space. So let's see now. You see now it has written false. So it's not there. So this is very important, because the space is also a string in Python. So now you can see that it's there. Good. Let's look at list indexing. Indexing in list is basically a way to actually identify the position of a particular element in a list. And we do this by positive or negative indexing. So positive indexing means that we start counting from left to right. While negative indexing means that we start counting from right to left. So positive means we count from left to right, negative we count from right to left. So good, let's start like this. The first element of a list from left to right is 0. So this is 0, this is 1, 2, and 3. So if I want to do this, I will say, so this is item. So if I want to look at the first element, I will do something like this. You can see now it's going to give us 5, because 5 is the first element. So, and Python uses zero indexing method such that the first element is 0 and not 1. So we use 0 to represent the first element. So when we say item into 0, we have 5. Item into 3. So that is, item into 3 is not the third element, it's the fourth element, because we start from 0. So 0, 1, 2, 3. So we are going to have tire. So if I ask for something that is out of the range, so we have 0, 1, 2, 3, and I want to ask for 5, it's going to throw an error. You can see now list index out of range, saying that this particular index we are asking for is not contained in this particular list. Now let's talk about negative indexing. So negative indexing starts from -1. So this here is -1, -2, -3, and -4. So if I write -1, so when you put -1 means the last element of that list. And in our case here is tire. So let's see. You can see now that is the last element. So if I want the second to the last element, I can say -2. This is very, very important. And if I want to go for more than one element, I can say from -2, so we put a colon. So from the second element to the last element. So now, good. What I want us to see here is this. I wrote from -2 to -1 and it returns only 0. Why? Because in Python, this last element that we put here is always like the boundary. Let me explain this better. Let's say item to 0, from 0 to 3. Now, if you look at this is 0, 1, 2, 3. You expect us to have everything in this place because it's starting from 0. No. So it's going to start from 0, but it's going to end at an index that is 1 lesser than the last. So this concept is like saying from n to n minus 1. So that if we have 4 as our n here, the last element that is going to be shown is going to be 3. So here now, what we are going to be getting here is going to be 0, 1, 2. These 3 will not come out. Good. So let's check it. You see now 0, 1, 2. That is 5, 6, 9, and 0. It's not going to show. And that is right here when we have -2. This is our -2. And then to -1, this -1 is not going to show. That is why we have this one alone. However, if you want to have everything like the last 2 elements, usually the best option is just to make this open. When we make this open like this, it's going to return everything from -2 to the end. And then we have this. So if you do the same thing here, we have this. So this is how we can take some elements of a list. Good. Now we can use the index function. This is an index function to actually locate the index of a particular member of a list. So for example, if they ask you that we have this is the list of all of our customers and we have put that particular list in like a data structure, which is a list, and you want to know whether a particular name is inside that list. So what you're going to do is just to use the in, like the in operator to check whether it is there. So let's say names is equals to, let's say we have Shegun, then we have Lam. and then let's put one more. So Demlade. Now, these are the names in our list. So let's say that somebody want to be sure that lamb is among the names inside this list. So assume you have like 10,000 or millions of names. You can't be looking manually. So what you do is basic. Just use lamb in names. So it's true. So which means that lamb is actually in our list. However, what index is it? You can check. So we just say, so we are saying that what is the index of lamb inside this particular list called names. And you can see that lamb is 0, 1, 2 is 2. So our answer here should be 2. So good. So we can try all of this by ourselves too. I'm going to be giving us this particular notebook at the description of this video so that you can download it and use it to also practice by ourselves. There is what you call nesting of list. So we can have lists inside a list. You can see now this is a list, but this here is a list, another list, and then we have individual elements. So if I call nested list out, we are going to have this. So if I say that, so it means that the whole of this list is the first element of this whole list. And this whole list here is the second element, and 0 is the third element, and 89 is the fourth element. So if I call on nested list index 0, we are going to have this. So if I call index 1, we are going to have this. Now, if I want to look into, assuming I want to extract 3,000, this particular value, 3,000 out of this nested list, how do I do it? Then I move forward again. So I will start by saying, okay, where do we have our 3,000? We have it in this list. Where is this list? It's at index 1. This is 0 and this is 1. So it means that index 1. So let me run that. Then we have this. So 3,000 is where? Is at index 0, isn't it? So I put it there again and said, what I'm looking for is that for the first element of nested list, we want to check from the second element, rather, the second element of nested list, we want to check its first element. And by running this, we are going to get 3,000. Good. So we can practice this as much as possible. Then let's talk about mutability of list. Mutability, like I said before, refers to the ability of an object to be modified after it is created. So this mutability allows for dynamic changes to list content, making them very versatile for various programming tasks. This is very important, and as we continue our journey in Python programming um, career, you will see how much this particular property of a list is very, very important. So let's start with this. This is original list. Original list contains 134, 5, and all of these elements. So let me print it. You can see the content of the original list, and you can see that we use this function id here to check for the location where original list is stored in memory. Good. Now, we want to change the element of the fourth index. So this is 0, 1, 2, 3, 4. So 0, 1, 2, 3. So we want to change the fourth element, which is index 3. We want to change it. We want to change it to 23. So to do that, we will say original list. So we put this index. We are saying that anything in index 3, which is our fourth element, change it to 23. So, and then we are going to print our original list, and I want to be sure that original list still maintain the same memory location as before. So we run, and we run it. You can see that original list has changed. So we have removed this particular string and we have changed it with 23. And the location you can see here is still the same. So that is very, very important when it comes to list mutability. So we can change the element of a list. For example, now let's say we have list 1, which is just 1 and 2, and we want to add 100 to it. So we want this to become a list with 3 elements, and we want the third element to be 100. So we use this particular method. We are still going to be talking about list method, but just follow me here. We use this particular method to add hundreds to it. So look at what we have. You can see now that we have added another element to this list. And like I said before, lists are ordered. You can see that the new element follow the same order as the ones that were there before. So we can do another example. You can see this. We have item 1. So let me call it out. So if I append purple, I want to add purple to this list of fruits. I will use this method, and then what do we have? So I'm sorry, this will be item 1. So we have added purple to item 1. So good. So I believe we have been able to go through list, just an introduction, and I believe we now have a basic understanding of what list is, the fact that it is ordered and it is dynamic because it is mutable. And we can see that we can create a new list and we can check whether a particular member belongs to a list or not. We can do both positive and negative list indexing, and we can actually locate a particular index where a member of a list is. And we spoke about nesting, how a list can actually be a member of another list, and how we can extract a member from a list inside a list. Thank you very much. We are going to be meeting in the next one.